A particle of mass 0.4 kilograms, projected horizontally, and it's projected with speed 2 meters per second. And after t seconds, it's now x meters away, so I'm going to take that as being positive. That's our velocity now after x meters or t seconds. And we got a force, resistant force of 1.6 v squared. So we got a variable force, so we have a differential equation. Here we go. Find expression for dv by dx. It's even told us what to do. So we're going to resolve. I'm going to resolve in the direction which is positive. I'm then taking that to the right to be positive because v is positive. And resultant force equals mass times acceleration. So that'll be minus 1.6 v squared equals the mass 0.4 times by the acceleration. Now acceleration could be for differential equation dv by dt, but this one obviously it tells us what to do, and so this will be v dv by dx. Now what can we do here? Obviously divide both sides by v, and then divide both sides by 0.4, and that gives me that minus 4v equals dv by dx. Done the first bit, hence show that. Okay, so I have to solve this, times both sides by dx, so minus 4. Well, actually I want to get the v on the other side, so minus 4 dx equals 1 over v dv. That separated everything, put in the integral signs, and that says that minus 4x equals ln v plus c. Always put the plus c, and now let's find it. So when t equals, when x equals 0 in this case, when x equals 0, v equals 2, therefore therefore c will equal negative ln 2, and we get minus 4x equals ln v minus ln 2. I can put the rules of lns and logarithms, I can put those together. So that'll be a ln minus 1 will be the same as the ln of the quotient, so v over 2. And now I want to get rid of the ln, so I'm going to e it, and that'll give us e to the minus 4x equals v over 2, and therefore v equals 2 e to the minus 4x. That's done the first part right in the middle of my page, so I'm going to struggle. Let's do it down here. I'll do it in red as usual. So part 2, find the distance travelled. So I've got to find x when t equals 0.5. In order to do this, I need an equation with x and t's, so I can replace this v by dx by dt. So dx by dt equals 2e to the minus 4x, and I want to get all the t's on one side, so I have a dt up over here. Oh, I was thinking 2 at the same time. dt up there, the 2, and I want to get the e to the minus 4x over to this side. So that would be, basically I would have times both sides by e to the 4x. And the sign has changed because that's 1 over e to the 4x and times in both sides by e to the 4x. And that'll have a dx in there, and then put in the integral signs. That bit, integrate e to the 4x, will be a quarter of e to the 4x, and that will equal 2t plus c. Always put the plus c, and we know when x equals 0, t equals 0, therefore c equals, let's be careful here, because e to the 0 is 1, and so therefore we'll have c equals a quarter. And that's going to give us a quarter e to the 4x equals 2t plus a quarter. Put it up here, and what we want to do is we want to put in there sub t equals 0.5. and we get a quarter e to the 4x equals 2 times 0.5 is 1, plus 0.25 is 1.25, times both sides by 4, e to the 4x equals 5. Get rid of the e to bit, so therefore ln both sides, and that gives me 4x equals ln 5, and then divide by 4, x equals a quarter ln 5. And you could work that out as a number, but there's no reason why you can't give it exactly. And that's question 4 done.